Three rockets take off and follow a parabolic trajectory to their landing sites. Using three different methods for finding the x-intercepts, let's figure out where each rocket will land. Starting with rocket number 1, we're going to use a method called completing the square. Completing the square entails creating a perfect square binomial. Since your current equation does not factor that way, you need to do some algebraic manipulation first. You need to move your y-intercept over to the right-hand side and make sure that your coefficient in front of the x squared term is 1. Now, to make our perfect square binomial, take half of the b term, square it, and add it to both sides of your equation. This creates an expression that you can factor into a perfect square binomial on the left-hand side. The rest is simple. Now use algebra to solve for x. Keep in mind that whenever you take the square root of a number, there are two possible solutions. When we think about a parabola, it makes sense that there may be two solutions possible, since our parabola crosses the x-axis in two locations. For this problem, however, we're looking for the distance the rocket traveled, so the positive solution is the only one that makes sense in this context. Now on to the second rocket. For this example, we're going to use a method called factoring. When possible, this is the quickest and most efficient method for finding the x-intercepts of your quadratic equation. I like to think of factoring kind of like a puzzle. You need to create two polynomials that when multiplied will get you back to your original equation. For this example, it is clear that both of your first terms need to be x, one of which is negative, in order to multiply to get negative x squared. For the next piece, you need to find two numbers that multiply to 12 and add to 4. Use the distributive property to make sure that your two polynomials multiply back to your original equation. Using our factors and the zero product property, we can now solve for x. Either negative x plus 6 equals 0 or x plus 2 equals 0. Again, you'll notice that we have two possible solutions. Since we're talking about the distance that the rocket traveled, the only one that makes sense in this context is x equals 6. Now on to our third and final rocket. This time, we're going to use the quadratic formula to solve for our x-intercepts. Using the quadratic formula is not as quick as factoring, but it works on every quadratic equation. First, we need to identify a, b, and c in our equation. Then, take those values and plug them in where appropriate. Now, use a calculator to do the arithmetic. Keep in mind that again, you have two possible solutions to account for. Be careful with your signs and your order of operations. Since we're still describing distance, we're only going to use the positive solution. Using an app like Desmos, we can graph all three equations and take a look at the parabolic trajectories of all three rockets. Notice that this graph confirms the three landing points that we mathematically calculated. Want to learn more? Visit the Reduced Simply YouTube page.